Okay, Shabab. We would like to continue with what we have started with, the body plot. Okay, last time we stopped at the complex conjugate, if I have complex conjugate poles or zeros. So let's start by, again, refreshing your memory about suppose I have the complex conjugate pair. I suppose it's a pole, pair of pole in this way. Okay. So I would like to obtain the magnitude of this one. And as you remember, what we are going to do straight line approximation. Okay. So if this is the magnitude, then let me collect the term in here. So basically you will have over the j square will be -1. So I will have 1 minus omega over omega n square plus j2 zeta, okay, omega over omega n. If I want the magnitude, what will be the magnitude? What will be the magnitude of this quantity?
1 over
1 over
square root of 1 minus omega over zeta square all squared plus
plus 4 zeta square,
yeah,
omega over omega n square. This is the magnitude. So we have take 20 log of the magnitude. This is in the denominator. I'll put it in the numerator. It will be negative. And this is, if I take out the square root, it will be just, this is the quantity. Okay. So now, any question here before we continue? Now, how about by the way, how about the phase before I continue? What will be the phase in here? What will be the phase? Any suggestion? How do I find the phase of this system? It's in the denominator, so it will be minus tangent inverse of what?
بسيطة يا دكتور. عندنا أصلا شو اسمه الواي أوفر إكس، بالتالي عندنا الأوميجا أوفر أوميجا إن 2 زيتا أوميجا.
It's going to be
yes
2 zeta omega over omega n
omega over omega n
omega over omega n square. This is the phase. Okay, so again, as I said, this is the phase.
بلس ولا ماينس صح دكتور؟ اي
ماينس because it's a denominator.
اي اذا لا ماينس قصدي اللي في الدينومينيتور لانه جيب سكوير ماينس. تمام.
This one. You are talking about this one, Abdurrahman?
Yes.
Okay. Now let me go back to the approximation. I want to do the approximation here. Okay. Let's omega, as I said, I want straight line approximation. So let omega over omega n much smaller than 1. So let me come in here. What will happen to this term? What do I have?
You'll only get 1.
You have 1. And this term, because if I'm ignoring this term definitely, first I'm multiplying it by zeta squared, so definitely it's going to be smaller. So the overall approximation will be log of 1, which is equal to
0.
20 log equal to 0. How about omega over omega n? Much greater than 1.
هذا الابروكسيميشن دكتور. We will use it in plotting يعني.
Hey, Bill plot, yes.
تمام.
Okay. So now, if omega over omega n much greater than 1, so I will ignore the 1 in here. And this is going to be to the power 4. Again, compared to this one, this term is much bigger. So it will be, and it's going to be to the power 4. You take the 4 out. So 20 log of the magnitude equal to minus 40 dB log omega over omega n. Which means that I have, okay, my approximation, it will be 0 until omega equal to omega n. And then it will go by slope of minus 40 dB. As if I have two simple poles at the corner frequency. So the complex conjugate will be treated as two simple poles located at the corner frequency at omega n. Any question?
طبعا هنا دكتور هتكون minus 20 or minus 20 dB.
No, minus 40 dB.
ليش minus 40?
This is, ignore this one. You will have.
Oh, we have 4. Yeah.
2 and 2, 4.
Yes.
Okay, of course in here, at the corner frequency, suppose, okay, what about omega equal to omega n? Sorry.
ايش اللي صار؟
السؤال, okay, let me read. The 20 log of the magnitude at omega equal to omega n. This is equal to what? Come here. If omega equal to omega n, what do I?
This will be 0. This part will be 0.
This part will be 0. How about this part?
This will be 4 zeta square, so we can.
4 zeta square.
Yes.
Okay, so it's going to be. So it is, if I put a 2 in here, so it will be
2 zeta
it's
and
going to
then
be
minus 20.
20 log
2 zeta.
2 zeta.
Zeta, yes.
Which means that in here, if I want to sketch it, at the corner frequency, it depends, you know, the approximation depends on the value of zeta. In the case of the simple pole, at the corner frequency, I can go just 3 dB points. But in here, no, it depends on the value of zeta. The correction, you know, your approximation is, you know, how good is your approximation depending on the value of zeta.
Yes.
Okay? What about, okay, this is for the pole. What about for the 0? What about for the 0? If I have set of complex conjugate zeros, what do you think the graph will look like?
مرة ثانية دكتور، ايش تقصد بالزيرو؟ الزيتا زيرو يعني ولا كيف؟
What I'm saying, and هنا we have the complex conjugate pole.
تمام.
Complex conjugate 0. The slope will be, the slope is going to be, this is the shape, isn't it? This is the shape. The slope is going to be positive.
كومبلكس كونجكت زيرو في الزيروز يعني نتكلم على الزيروز هاي تمام.
Suppose you have this is simple pole. If I have a simple 0.
Always دكتور the zero is the يعني the negative of يعني.
Exactly. It's going to be, I mean.
Symmetric with respect to
the slope will be positive.
Yes.
Slope is going to be positive. Okay. Well, so as I said, the approximation in here is going to be, you know, 0 before the corner frequency. It will be, if you have poles, minus 40 dB per decade after the corner frequency. Of course, the angle will be is a little bit, again, a little bit more complicated, because in the angle, I will have, let's say, 0. If this is the corner frequency, let's say this is omega over omega n, or sorry, this is omega n, then I'll take omega n over 10, 1 decade before, and omega n on 10 omega n. So it will be 0 in here is going to be, in this case, what will be the angle if I have two pair of complex conjugates? Ultimately, the angle will be what? If you have pair of complex conjugate poles, if omega go to infinity, what do you get? What's the angle is going to be?
180.
180. So it goes to be minus 180, and you connect. Because each pole will contribute 90, so you have two poles, it's going to be 180. Okay? Now let's take an example which contain something is went wrong, is wrong, getting I don't know, I'm not getting the, I don't know what happened. Okay, suppose I have, this is my system. I would like to see the body plot, okay, for this system. It's already given in the format which I want. Okay, sketch the body plot for this system. First of all, what are the corner frequencies? What are the poles and zeros of the system? What are the poles and the zero of the system? Can somebody tell me?
Yes, for the zeros, for example, we have 1 plus j point
Where is located? Where is located?
قصدك يا دكتور في السيجما جي اوميجا بلين.
Yes.
Yeah, it is on the right half plane. It is.
What is it? What is it? Value. Abdurrahman, imagine this is a transfer function. What is the location of the zero will be?
والله يا دكتور, I didn't get your question صراحة.
Okay, I have 1 over 1 plus j 0.1 j omega. This is came originally from 1 over 1 plus 0.1 s. This was
صحيح. تمام.
So where is the pole?
تمام. You solve it will be 0.1 s equal 1 plus 1.1 s equal to 0.
Which is
right?
s equal to what?
Which is minus 10.
Exactly.
So it will be in the sigma axis.
So okay, no, location. Give me location. 0 from here at 10. And I don't have any other 0.
At 10 or at minus 10, دكتور?
Minus 10, doctor.
No, in the frequency in here, the pole located at minus 10, but in here, in the graph paper, we are taking positive. So we take.
Yes. Yeah, because يعني احنا الفكره هنا انه هذا يتكلم عن اوميجا شو اسمه الكورنر فريكونسي اللي هو يعني before 10 we will ignore omega.
Okay,
after
no,
10 we will ignore 1.
Abdurrahman, wait a minute. Let's take it one at a time. Now let me locate the poles. Shabab, the poles. Where are the
طيب عندنا 2 وعندنا
0
and 0.
Yes.
Okay. So the poles are at 0 to 50-50 and 0 at 0.
طبعا 50-50 هذه يا دكتور لازم نحل الكوادراتيك ايكويشن هذه صح؟
ما نحل شيء. It's already in the format which
لا صح هي في الفورمات صحيح.
It's already in the format which we have. If it's not in the format, you have to do, you have to work it out such that it will be in this format. Okay. Now, before we start, let's have an idea. Let's have the roadmap for the question. We should worry about what is the initial slope and what will be the final slope. What will be the initial angle? What will be the final angle?
Doctor.
Yes.
The 50 and 50, how did you get it?
Well, he said this is complex conjugates. In this format, okay, we are approximating the system. If you remember, we said we consider the system as this is omega n. It means I have 0 before, and after I will have minus 40 dB, as if I have two poles located at omega n. With this approximation, with this format, okay, I'm approximating my system. I'm ignoring, okay, as if, look, I'm as if I'm factorizing my complex conjugate, okay, into two simple poles, and those poles are located at the 50.
Okay.
Okay?
Okay, clear.
Okay. Now, as I said, what will be the initial slope from here?
For the balls, Doctor,
No. What will be the initial slope of the system? How do I start?
المفترض we start with 0.
We will have what?
We start with 0 ولا؟
No.
I think
Shabab,
it will be the
minus
slope.
20.
Hello. هلا. يا أخي عندي محاضرة لك ممكن أنتوا على المحاضرة. أيوة.
Minus 20.
Exactly, minus 20, because this is the pole which we have. So I will start by minus 20. What will be the final slope? Final slope equal to 20 times, okay, number of zeros minus the difference between them. Remember,
minus 60.
remember in the root locus, we were calculating how many asymptote, the difference between poles and zeros. And here, the same thing. Okay, so in this case, I have how many 0? 1 0.
Yes.
How many poles?
4 poles.
4 poles. So I will have 20 times minus 3, which is equal to minus 60.
One is contributing positive, and the poles are contributing
Exactly,
negative.
exactly. Okay, so by the same token, what will be the initial angle? The initial angle will be minus 90 because of this pole. What will be the final angle if omega go to infinity? Angle (90) times the which is equal to what in this case?
Minus 20, minus 90.
Minus what?
Minus 20, 270. يعني it is
270. 270.
Yeah. So it is 90. يعني.
Okay. So basically, before you start, you should have an idea. You should start at a slope of minus 20. You end at minus 60. The angle you start at minus 90. You end up by minus 270. So before and then start filling the gap. So at least you know what is the target. Now, let me come back. The first term I will have to worry about is the constant. So if I want to sketch the constant, the 5, okay? I will take what? 20 log 5. What's 20 log 5 equal to?
13.9.
13. So this is the first one. That's constant.
تمام.
Okay. Then I have to worry about the zero, the initial slope.
ما الزيروز يا دكتور ليش ما بدت بالزيرو؟
كيفك؟
مهم.
This is the easiest one.
تمام.
Okay. Now, I have to worry about the initial slope. We said it must be minus 20 dB per decade. But
Starting from 0, yes.
But it is coming from, let's say, minus infinity, or from, infinity is coming. But it's important in here, what's my scale? If my scale is 0.1, what will be the contribution here? If my scale is 0.1, so you will take minus 20 log 0.1, which will be what?
It will be 20.
It will be 20 because this will give you minus 1. So it will be, and then at 1, it will be 0. So this is coming like this, and will continue.
And it is kind of, slope is 20, so you determine the points accordingly.
Well, how do you determine the slope? You have to locate the points, okay? And you determine 20 dB, okay? Anyway, you want it. But what I'm saying, it's very important. I find the initial value. Okay.
اللي هي دكتور the least value في y axis.
No. It depends on, look, it depends on what you have. In this particular case, my first pole start at 2. So my scale, I can start at 1, but usually I will take 1 decade before. But if I have, let's say, j omega, and this is, let's say, I will have, let's say 1 plus, 2 j 2 omega. What will be the pole? Where is the location of the pole?
We have 0 and we have
the pole. Where is the pole? This is 2.
1 over 2. 1 over 2.
It's 0.5, isn't it?
Yes.
0.5, I should go 1 decade before. So I should start at 0.01. My scale will start at 0.01. You always try to go 1 decade before the zeros and the poles. Before the first pole or 0. 1 decade before you go. So it depends. The scale which you use, it depends on, it depends on your system. Now, let's go back in here. Next, I have the pole at 2. We said, if this is the 2, what will be, what will be the value, what is the contribution of this pole? Before 2, what do I have? What did we say?
We have
only
we have constant for the.
It will be 0, shabab. 0, then minus 20 dB per decade.
Yes.
Now for the 10, what do we have?
بس هنا it will be plus 20.
دقيقة عبد الرحمن دقيقة خلينا.
Plus 20 dB.
جاسم اليوسف.
Yes, doctor.
Okay, what will be the contribution for the 0 at 10? How do I sketch it? If this is the 10.
It's not minus 20.
No, it will be, this is 0 before and 20 positive because it's 0.
Minus, I mean.
دكتور بس can you put for this line 0 كده على اليسار عشان بس السكتش يكون واضح.
Okay, well, I thought, okay, just one second. I'll do it in a better way. Okay, the constant is 13. This is, I call it curve number 1. Curve number 2, minus 20 dB per decade. Remember, we said this is 0.1.
طيب سؤال يا دكتور, why we didn't start from 1?
Why don't you start from 1? Because if, okay.
If we do so.
If you do so, you will have, your graph is not very accurate, especially when we go to the angle. Remember the phase.
The phase has the
I need 1
problematic.
decade before.
Yes.
Okay. So this is 2. 3 is at 2. This one. It will be 0. And then at 2, this is 2 minus 20 dB per decade. For the 0 at 10, it will be 0 and then positive slope. The last thing is I have the frequency at omega n, which is 50. So I'll come all the way to 50, and then the slope will be what? What's the slope is going to be?
minus 40 dB per pixel.
Minus 40 dB, because I have 2 poles at 50. Now, the overall, just add them. Add. So the initial point, if I want to add, what would be the initial point? The at point 1.
We have to إلى شو اسمه إلى 2, but yes, we have to add them. Add these. It will be. We will raise this red line up.
Okay, so I'm having those 2 will be 34. Around 34. Okay. I will continue with this curve until I reach where?
Until you intersect with 3.
No, until 2.
Like قصدي 3 الكيرف 3 يعني مش.
Curve 3, yes, which is the value. I mean, the value is 2.
It's 2, right? Yeah.
So this is 1. So at 2, okay, the slope will be what? What will be the slope?
Will be minus 40 dB.
40 dB until 10.
Yes.
Until 10. Shabab, wait, let me. Mamoon. Mamoon?
Yes, doctor. Yes.
Okay. Now, at 10, what will be the slope? After 10. I have, we said originally minus 20, minus 20. Now I'm adding 20 because the 0 is positive. The slope in here is positive. So minus 20, that will be minus 40, plus 20. So between
Minus 20.
it will be, okay, after 10, exactly, it's going to be minus 20 until 50. After 50, what will happen? How much I will add? After the 50, I'm adding minus 40 dB. So the final answer will be minus 60 dB. And that, if you remember, that's what we said at the beginning, before we start.
طيب دكتور سؤال.
تفضل.
زي فضلك الآن مثلا يعني I don't want to be exam oriented بس يعني just a question. مثلا في الاختبار ممكن تجيب لنا أسئلة تحدد مثلا الدي بي والأشياء هذه بس مثلا هل في مثلا سؤال ممكن يقول sketching بس كيف we'll do the sketching يعني part.
Yes, we could have. Okay, look, if it's in person, I used to, you know, if you are in here, for example, take the, well, let's take the homework. In the homework, yes, you have to sketch by yourself, by your hand.
نطبع مثلا من الانترنت ورقة logarithmic scale.
Yes, semi-log paper and use it.
And we use it, yeah.
Yeah, of course, because we have the kind of multiple choice and, you know, so either we will give you the transfer function and we'll give you multiple graphs. Choose the proper graph. Or you are given the graph and you have to reverse the process, figure out.
Oh, this is problematic.
Figure out the
لا دكتور.
identify the transfer function.
لو أعطيتنا مثلا هذا الجراف اللي هو الأزرق أو هذا يعني صعب جدا إنك أنت تعرف.
No, it depends on the complexity. Yes, it depends on the complexity. But this is, you know, I mean, in real life, it is data. You have given data. And from this one, there is, you know, there is a topic called system identification. Okay, you have a system, and you don't know what's the order of the system. So you're excited by giving the frequency response. You will get the frequency response, identify from it, identify what's the transfer function of the system. So it could,
هو دائما 3 problems المعروفة. Either you know the input, you know the black box, you want to know the output, or you don't know the black box.
So anyway, so it could be, I mean, as far as the, if you are worrying about the exam, yes, well, if the exam in person, possibly we will give you the graph paper and then we ask you to sketch. So you have to be careful. You know, the problem is most of the time, people, they don't practice on similar graph paper. And when you come to the exam, if you don't practice it before, it will be a mess.
It will be really a mess.
It will be really a mess. But if you practice it, no, it will be, I mean, it's regular. Okay, now look, this is as far as the magnitude. Let's go to the phase. Okay, again, in the phase, what do I have?
It's like a snake, Doctor.
Well, now in the phase, look, to start with, what's the contribution from the pole at 0?
We have 90.
Okay, I will
Minus
90,
90.
minus 90, and it will be constant. So this is the term. Okay. Majid.
ايوه دكتور.
Okay, Majid. What is the contribution of this pole at 2? Okay, we said, if you remember, if this is 2, so how do I do the approximation? Any idea? Any idea?
I was muted, sorry. It's 0 until 2, then decrease with slope 20 dB.
No. In the phase, we will go 1 decade before, so we'll go to 0.2 here, 0.2, and 1 decade after, which is 20. So it will be 0 at 0.2, and it will be minus 90. Okay, this is minus 90 at 20, and then I'll connect. And we said then in that case, what will be the slope? I'm going minus 90 in 2 decades. It means that the slope will be
minus 45 per decade.
Exactly. Thank you. Exactly. So, okay, for the 2, look, the 2, this is the 2. This is the 2 in here. Okay. So I will at point 2, which is this one, I have a 0. And then at 20, this is 20. Okay, I have 90, minus 90. Then you connect. The next to them is the 10. You come to the 10. This is the 10. So I should be at 1. Okay. At 1. And then at 100, at 1 it will be 0, and at 100 it will be 90. So I will be in here.
Yeah, so this is kind of a rule, Doctor. This is always followed in the phase.
Yes. This is the approximation. This is the approximation. It is interesting. You look, when you have it, okay, and then of course the 50. This is the 50.
5 and 500.
At 5 and 500. This is 500, and this is 5. Now in here, the problem with the approximation, in addition, I mean, it will be very messy. This is the range which you should work with. Okay? This is the range. It will.
Allah, the exact, Doctor, it's like a snake, يعني.
كيف؟
The exact curve. Do you hear me, Doctor?
I will give you the exact later, but the approximation, look, the approximation definitely is not going to be that accurate. If you want to do any design, look, That's where we will go when we do the design. We usually get these days, you know, I mean, when I
MATLAB.
70s, there is no computer. There is no, now, you know, MATLAB is, you know, doing everything. In the design, you will get the exact, because
يعني
it will be very difficult, you know, to
سؤالي دكتور. Before MATLAB and before all this stuff, when you were taking such course and when you were designing for real applications.
Yeah, we were taking, believe me, we were taking this course and we were doing great.
لا مش اكيد ما شاء الله انتم يعني احسن منا بلا شك.
لا بس هو يعني look الكورس نفس الكورس، الكونسبت نفس الكونسبت، بس الحين الكمبيوتر بارت it's you know it's different and it's helping. يعني in there
يعني قصدي دكتور في مثلا مشاريع التخرج او يعني ايامكم لما كنتوا تدرسون مثلا
yes
هل you went through whole processes using يعني pencil and paper and you did everything by يعني hard way, you didn't have the luxuries of MATLAB or Mathematica?
Well, no, in there, look, maybe, you know, well, in the, for example, in the 380 lab, okay, we have what we call analog computer. I wish they have left one like a museum. They put it in the museum. The analog computer, basically, if you look at the block diagram, where you have integrators, okay, and you do the simulation, it's computer. You will do the simulation, okay, exactly the same way you are doing it now. But because analog computer, and you have to, you know, figure out the gain, different gain which you want. And of course, now when you do the design, definitely it's not going to be that accurate. It's not going to be that accurate. But no, look, this is human, okay? يعني
ايامكم هذا الانالوج كمبيوتر دكتور يعني
by the way the computer we do have computer, you know, we have computer but not it's mainframe. It's not
يعني ما هو كمبيوتر زي الحين يعني مثلا
كيف؟
اقول ما هو كمبيوتر مثلا نفس الويندوز والاشياء هذه.
لا وين هذا الويندو وين ما طلعت متى؟ نو البريك ثرو هذا بعد ال 90 بدات البريك ثرو يعني. لا من اول no. So it is, you know, I mean, look, life is dynamic. يعني الحين I think if you talk about بال 1800 كانت الثورة الصناعية، اوكي؟ يعني التوربين، اوكي؟ الاسمبلي لاين later on الاسمبلي لاين. الحين مع الانترنت this is يعني الانترنت is now as you move. يعني when you were a kid, okay, look, I bought to my son when he was in the primary school صخر. There is computer called صخر بالعربي. للأسف they did not develop it. They stopped it. Okay. And then things become, you know, more and the computer was okay. You talk about floppy disk. The memory was, you know, is nothing. So things are changing. Look, things are changing, but okay. The change, we should, you know, benefit from this change by now, you know, the simulation is higher order system. You can do a lot, okay? Unfortunately, most of the people nowadays, they go to simulation rather than the, you know, mathematical proof of certain things. But anyway, it is interesting and it is, you know, I mean, life is changing. Look, as I said, the approach is the same. I mean, or not the approach, the concept is the same. I mean, root locus in the, I think we said by Evans, which is 1928 or something.
Yes, the idea is
the same, but now
as electrical engineering, as an electrical engineering, you are observing such advancement in technology. What's your impression about this advancement? How did you see such advancement, and you are a scholar in electrical engineering, and you are contributing to such advancement?
Well, look, you can see daily in your life things are now. Look, in the 70s, if you see somebody walking in the street talking to himself, you said he's crazy. Now you will see many people, they are in the street, they are talking, and you think they are talking to you, but they are talking to in the mobile. They are putting the not only
AirPods.
there is, people were dreaming that, you can talk and you see the person in front of you. Okay. So the mobile, what happened to the mobile? You remember it. I don't have to, at home, we used to have the fixed line. And not everybody has there's no mobile. Now, nobody's using the fixed line. I think everybody's using the mobile.
صحيح فعلا.
So everything, life is changing. The technology with the modernization, with the computer, now people, moving, definitely differently. Now they are talking about, maybe in certain few years from now, the cars, okay, you don't need driver. It's auto.
I think, Doctor, it's very interesting if we can conduct like a session talking about this, because I remember one professor, I think he is electrical engineering or computer engineering, when Steve Jobs comes with his computer, they sent to the university, I think, a version of that computer, and one of your colleagues at that time sent to Steve Jobs a modification and a problem, and Steve Jobs acknowledged such issue, and he resolved such issue. So it's the and what I'm looking for, what's your contributing for such advancements, because I believe all of you, our professors, have a huge contribution to such advancement technology.
مشكلتنا يمكن هنا in Saudi Arabia, we do a lot of research. Okay. Most of basic research. Okay. The application, we don't have, in the States and Europe. The industry is supporting a lot. You have something, you can, check it with the help of the industry. In here, in recent years, KFUPM, there are many patents, we are doing great in patents, but the problem is how do you convert it into something which is industry, something which is useful, something
like شركات
economical. Okay. So basically, this is what everybody is. I will give you an example and then we'll go back to it. I remember when I was in the responsible about the technology transfer at KFUPM before I returned back to the teaching. One of the products which we have, leak detection for the water. We have huge pipelines in the kingdom. We are transferring water between, let's say from the eastern province to Riyadh. Okay. How much, we are losing because of the leak. So somebody came up with, a robot, you send it inside the, the pipeline, and it will tell you exactly if there is a leak in the pipeline. Okay. We gave it, there is one company in here, we work with them. They said you have to reduce the size of the, because, when you go to the junction, it will be very difficult. We did modification, but unfortunately they stopped, supporting. This is what we have. This is the problem what we have. Anyway, it is the dilemma. This is a dilemma for us. But anyway, let's go back. It's interesting. The discussion, very nice, but let's go back. Okay, now, okay. So as I said, add those together and then you will get the, your, wait a minute. Okay. If you want to get it by using MATLAB, look, in MATLAB, there is a command called body over the transfer function. It will give you the body plot. And this is basically the exact. Look at it. In here, the concept of gain margin, later on and phase margin, we will go to it. Okay. And this is, if you have your sketch, maybe you don't get it very accurately. But within the MATLAB, if you have the MATLAB, then it will definitely, it will be precise and your design will be much better. Well, what we want to go next is I would like to have certain performance specification in frequency domain. We always would like to go back to the time domain. Why do we? Why? Because in the time domain, you do understand, okay, the shape of the response. In the frequency domain, it's not very clear. And we'd like to relate. Is there a relationship from the frequency domain to the time domain?
Fourier transform.
For example, if I have a system with larger bandwidth, how do you translate this one to the
Less time.
what?
If omega is high or the bandwidth is high, so it will take less time. And
Which
it
means
is
that
kind
yeah, you can relate. So you relate, which is good. I want to relate the frequency to the time because ultimately, you know, we are living. I mean, this is the we do everything in real time. So what we want to do in here, let's study the second order system. We did the second order system. We give the specification in time domain for the second order system. Let's do the frequency domain specification for a second order system. First of all, what will be the transfer function of this system? What will
yes, it's will be feedback, unity feedback. Very simple.
any other person can help us?
Yes, doctor. Step by step. Omega n square over
Wait,
s.
Abdurrahman, wait, because I don't want the class between me and you.
Yes, doctor.
Yes, go ahead.
Omega n squared over s squared plus
Okay.
2.
Yes, omega n square over s plus 2 zeta omega n over 1 plus omega n
Squared.
square s plus 2 zeta omega n. Thank you. Okay, this is y of s to r of s. So neatly, this is what we have, which is, very similar to the second, this is the second order system which we have.
Yes, in the standard format.
If?
I mean, in the standard format.
Yes. Now, let me do the, frequency domain. What will be the magnitude of this one in the frequency domain? So basically, I'm looking for T of j omega. And then omega n square over j omega square.
We have to divide by omega n squared, doctor.
We can, yes. But what I'm trying to say, let me do the magnitude. So the magnitude, we can do the magnitude for this one by, first of all, substituting for s to be j omega in the frequency domain. Okay, this is zeta j omega plus omega n squared. And we can do the standard one. So basically, what we are going to sketch, if we sketch the magnitude, we are going to get a shape like this. Okay, which is very similar to what? This is for the second order system. This is similar to what? How does this resemble? What does this resemble?
Low pass filter.
This is it looks like the overshoot in the second order system. So in here, look, we define the resonance, okay, as the maximum value of the magnitude. And then I think we have 1 minute, and we will also define omega r or omega p, where the maximum peak we reach. And finally, the bandwidth. The bandwidth is defined as the frequency at which the magnitude dropped to 0.707 of the zero value, of the low frequency value. So those are a specification which are important to us and we can map them to the time domain. We already have said that if the bandwidth is larger, then basically what you will have, your system is going to respond faster.
دكتور فكره 3 دي بي اللي هي 1 over root 2 صح؟
Exactly.
اللي هي الهاف باور.
Okay. Yes, it is the cutoff frequency.
half power لانه دائما احنا we assess in terms of the power
Yes.
because after we lose the half power of the signal, so we shouldn't worry about the other thing.
That's correct. So anyway, let's stop in here. Okay. Have a nice weekend, and we'll continue.
Victor,
Yes.
please, this magnitude sketch for any values of zeta and omega n.
The magnitude. Say that again. Magnitude.
This sketch, is it for zeta between range, a certain range, or it is arbitrary?
No, this one is a general. If you take it, it will look. Let me go back. Shabab, the class is over. Anybody want to stay? Look, take m of s equal omega n square over this quantity. Okay. Then let's substitute and then divide by omega n. Okay. So tell me, what will be the magnitude? What will be the magnitude? The magnitude is going to be 1 over 1 minus omega over omega n square plus 4 zeta square omega over omega n. Sorry, omega n.
Square.
And this is okay. This is going to be under the square root. And this is 1. If you sketch it, okay, if you sketch it, it will be, it will, this is basically, sorry, if you sketch it, it will be in this shape. It will be in this shape. This is very general, okay, but the behavior, of course, it depends on, we are going to see the peak value and this one, they depend on zeta and omega n. If you remember, in the second order system, the overshoots depend on zeta. So this is similar behavior which we are going to see. Is that your question?
Yes. Thank you.
I have a question, Doctor.
تفضل. But
I have a question.
let me stop recording.